Good evening, Titans. This is Mr. Sturts. We are on lesson 3.6, part 2. Before we had translations and reflections, tonight we're going to have stretches and shrinks. Moving into our core concept, horizontal stretches and shrinks. Okay, and what this means, focus on this right here. We have y equals f of a times x. If we have a number being multiplied in the middle of our function there, we know it's going to be a horizontal stretch or shrink. In this, the y-intercept stays the same. So if that number being multiplied to x is greater than 1, we're going to have what we call a horizontal shrink, and it shrinks towards our y-axis. If that number is between 0 and 1, it's going to be what we call a horizontal stretch, which means it stretches away from our y-axis. Moving to vertical stretches and shrinks, if we have a number being multiplied to our whole function, it's a vertical stretch or shrink. And on these, the x-intercept stays the same. If the number being multiplied is greater than 1, we have what we call a vertical stretch. It stretches away from the x-axis. If it's between 0 and 1, we have a vertical shrink, which means it shrinks towards our x-axis. Alright, our first example here, our parent function, or our original function is f of x equals x minus 1. We need to graph, let's graph part A first, g of x equals f times 1/3 x. Okay, so how we're going to go about this is we're going to make a table. Alright, just like the part 1 of this section, we're going to make a table. And we're going to have some x values. We're going to have a 1/3, 1/3 of x. And we're going to have f of 1/3 of x. Okay, and we're going to complete our table here. We're going to plug in a couple values. We're going to plug in, for this example, -3, 0, and 3. Now, 1/3 of x, of our original number there. So 1/3 of -3, we get a -1. 1/3 of 0 is 0, and 1/3 of 3 is 1. Now, our function says 1/3 of x, f of 1/3 of x. So what we're going to do is we're going to plug that back into our original function here. So -1 minus 1 is a -2. 0 minus 1 is a -1. And 1 minus 1 is 0. Okay, now let's graph. Okay, we want to see what this transformation does. Okay, if we graph our original function x minus 1, we know our y-intercept's at -1, so we're going to plot our point. And our slope, if there's no number before x, we know it's going to be 1. So we're going to go up 1, right 1, plot a point. And we're going to go up 1 more, right 1, plot a point. Okay, if we connect our dots there, we have our line. Now, to figure out this translation, we're going to graph the ordered pair x and f of 1/3 x. So we're going to graph our top numbers, and our y-coordinates are going to be our bottom numbers. So that first ordered pair is -3, -1, 2, 3, -2. So we plot a point here. Our second point is going to be 0, -1. Okay, remember that y-intercept doesn't change on these. And then our last point is 3, 1, 2, 3, 0. So if we connect these points, we can see here that we have a horizontal stretch because it stretches away from our y-axis. That line stretches away from our y-axis. Like we said before, that number being multiplied by x is between 0 and 1, so we're going to have a horizontal stretch. And that's our part A. Let's get this erased. And we're going to work on part B here. Okay, now part B says h of x equals 3 times f of x. Okay, so again, let's make our table. Okay, we're going to always start by making our table here. We're going to have x, we're going to have f of x, and we're going to have 3 times f of x. Now, we have a number being multiplied by our function. Okay, so like we said before, we know it's going to be a vertical, either stretch or shrink. If we plug in numbers, let's plug in 0, 1, and 2 for this example, and plug these into our original function for f of x. So if we plug in 0, we get a -1. If we plug in 1, we get 1 minus 1 is 0. And if we plug in 2, we get 2 minus 1 is 1. Now, 3 times this second number. So we have 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. And let's graph. Again, let's graph our original function, which is x minus 1. So we'll go down to the y-axis, plot a point. Our slope is still 1, up 1, right 1. Let's go up 1, right 1 again. Plot another point, connect our lines. And it's a vertical, so let's go ahead and graph our ordered pairs here. Again, we're going to use the top and the bottom. So 0, negative 3, 0, negative 1, 2, 3, plot a point. 1, 0. Since it's vertical, our x coordinate does not move. Okay, and then 2, 3. So 1, 2, 3. Let's go up here. Connect our points. Now notice here we have a vertical stretch. Okay, it's actually a vertical stretch by 3 because 3 is what we're multiplying to our function. So it stretches away from our x-axis. All right, let's do 2 more here. Now we have f of x equals x plus 2. We need to talk about our shrinks. Okay, we did our stretches before. Now we need to talk about our shrinks. Let's go ahead and again make our table. That's always going to be our first step here. X. And then we're going to do what our function tells us. 4 of x. Or 4 times x. And then our last one is f of 4x. Okay, we made our table. Now let's plug in some points. Oh, for this one, let's just use negative 1, 0, and 1. And we're going to do 4 times x. X is our original number, so we get a negative 4. 0 times 4 is 0. And 4 times 1 is 4. Now it says f of 4x. So what we got for 4x, we're going to plug into our original function, which is x plus 2. So negative 4 plus 2 is a negative 2. 0 plus 2 is 2. And 4 plus 2 is 6. Okay, and let's go back to graphing again here. Graph our original function, x plus 2. 2 is our y-intercept. Plot our y-intercept. Again, our slope is 1, so we're going to go up 1, right 1. Well, let's go 1 more, up 1, right 1 again. Connect our dots there. Now we got to plot our first and our second, our x and our y. So negative 1, 2, plot a point. 0, 2, our y coordinate's not moving. And 1, 6, way up here. If we connect our dots again, notice there we have a horizontal shrink because it's shrinking towards our y-axis, and that's by a factor of 1/4. Okay, let's do part B. Part B, we need to talk about our other shrink here. So again, we're making a table. And our table is going to consist of x. It's going to have an f of an x. And it's going to have 1/4 f of x. Okay, let's plot points again. Negative 2, 0, 2. Okay, f of x, plug it into our function. Negative 2 plus 2 is 0. 0 plus 2 is 2. 2 plus 2 is 4. Now 1/4 of what we just put, so 1/4 of 0 is still 0. 1/4 of 2 is going to be, it's going to be 1/2. Then 1/4 of 4 is going to be 1. Okay, if we plot our original function, go to 2, plot our point, up 1, right 1, that's our slope. Up 1, right 1. Now let's see what kind of shrink we have here. Now since it's a fraction before, we know it's going to be a vertical shrink by 1/4, but let's go ahead and plot our points here. Negative 2, 0. Negative 2, 0. And we're going to have 0, 1/2. And we're going to have 2, 1. Okay, and if we plot our line through there, notice it's a vertical shrink because it's shrinking towards our x-axis. Alright, moving right along. Transformations. We have 4 steps to see our translations. This is what we're going to compare them to. Y equals a times f. Let me erase that. I kind of got rid of a point there. A times f of x minus h plus k. Okay, and we're going to use all of these steps. The horizontal translations, we're going to look at the h. Okay, to use the stretch or shrink, we're going to use a, and to see the reflections, we're going to use if a is positive or negative. And then for the translations vertically, we're going to look for that k. Okay, so let's compare to this problem here. We can actually rewrite this, since f of x equals x, let's plug in f of x for x. So we can rewrite it as g of x equals -2 times f of x plus 3. Okay, all we did was substitute in f of x for x. Okay, now let's compare that to our original there. Step 1 says we're looking at the minus h for horizontal translations. Well, it's just f of x, so there is no horizontal translation. Okay, step 2 says we're going to look for vertical stretches. Okay, and what we look for there is we're going to look for the number being multiplied out front. There is a 2 being multiplied. Okay, so we know this stretches vertically. So we're going to have a vertical stretch by 2. Okay, because that 2 out front there, the -2 times f of x, tells us there's a vertical stretch by a factor of 2. Okay, step 3, we're looking for reflections. Okay, and remember, we look for if that's a positive or a -2 out there. It's a negative, so we know it is going to reflect over the x-axis. And last step here, we're looking for vertical translations. And that's where we're looking for the k, the number out back. Okay, since it says plus 3 right here, that's going to tell us it's a vertical translation. Vertical translation, since it's a positive 3, that whole graph is moving 3 units up. Okay, and that's using this last core concept there, comparing all of those, the variables a, f of x minus h plus k, to our original function here, and that's going to tell us all of our translations, whether they're stretches, shrinks, translations, reflections, up or down. These graphs can move all over the place. Okay, so we're going to clear some of these questions up that you might have in class. Thank you for watching the video. Please turn to page 89, do these 3 practice problems, see if you can knock them out. If not, we'll clear up your questions in class. Thanks for watching, and we'll see you tomorrow.